Good evening, good afternoon. This is the talk from the Minnesota Institute for Astrophysics, Universe at Home. Tonight will be about light pollution, the loss of the night sky. My name is Darcy Ballantyne.
Hi, everyone. I'm Anjana Tiladevara, and I am a graduate student at the Minnesota Institute for Astrophysics. I'm in my first year, and I work on supernovae research.
And hi, everyone. I'm Ramona. I'm a fourth-year undergrad studying astrophysics at the U. And I'm excited to talk about light pollution with you guys today. I want to point out before we begin, the image that you're seeing in the background, it's showing a beautiful picture of Ellington Island near Bear State Park in Minnesota. But you can notice the sky glow in the right corner, which is a form of light pollution that we're going to be talking about today. And so we're all really happy to be here, and thanks for your patience. And yeah, I'm going to start the story off here. Okay. So our story talking about light pollution begins with the invention of artificial lighting. So 150 years ago, the electric light bulb was invented, and none of us who are alive today can imagine our lives without them. But generations before us had to rely on different forms of light and get a little creative. So they would rely on candles and oil lamps up until, the 1700s, but they didn't burn super long, and I hear that they smelled quite foul and they gave off a lot of smoke. So on top of this, they're really not efficient sources of light. Candles are known to be 100 times less efficient than the light bulbs that we use today. In the 1800s, we moved on to gas lighting, and that was developed, and it is just as efficient as the oil lamps and candles used before it, except this was a change reflecting we were moving towards a shift towards like petroleum and the coal industry. So we started using gas lighting in our homes as well, and to light up outdoor streets. But then everything changed at the start of the 1900s, where the electric light bulb was invented. So for the first time, we had a light source that was able to last for up to and more than 50 days at a time. And this officially established electricity as the primary power source inside people's homes and outside along streetlights and stuff like that. So with brighter lighting, it became more common and safer for people to move around and be active at night. But this dramatic change meant a lot for the world around us. And we're going to talk about how this invention got the title as one of the most transformative milestones in history. So what is light pollution? Let's dive into that first. So the topic of today's show, although its impacts are really, really great, it has quite a simple definition. So light pollution is the over-illumination of cities and night skies by artificial light sources. Those sources include stadium lights, building lights, street lights, decorative lights, even the lights that we have escaping our windows in our houses at night. And this pollution is caused by the abundance of sources emitting light outside of its intended direction. And it's only really been taken recently as a form of pollution. It's a major side effect of urban living. Obviously, when you have more people, there's going to be more light. And we can see this in the satellite view over the Twin Cities of Minneapolis there. So none of this is to say that electric lights are inherently bad. Artificial lighting has extended the length of the productive day. It's offered us more time to be working and playing after the sun sets. But when artificial lighting becomes inefficient, annoying, and unnecessary, that's when it's known as light pollution. So next, we're going to talk about the three main types of light pollution, because there are flavors. So the first type is glare. And this occurs when we see an overly bright source of light hitting directly into our eyes. So this comes from sources that throw light in all directions, so some of it is bound to come and hit your field of view. And when you're driving at night in your car and the oncoming car light becomes quite uncomfortable, that's going to be an example of glare. And in this case, it's the angle going right off of the useful light zone right into that person's eyes. So light trespass is the second form, and it's the unwanted shining of light onto nearby areas. So light is falling where it's not needed or not wanted. In this case, the street light is not supposed to be lighting up the house, but it is. Sky glow is the third form, and it comes from light pointing directly upward or reflecting back from the ground. So this light is then, when it comes upward, it's going to be scattered by the dust and the water particles in the air. And it creates this glowing yellow halo that we saw in the opening image over inhabited areas and big cities. And this is the form of light pollution that really impacts most clearly like how we can see objects in our night sky. So we have to have ways to measure the sky brightness. And to do so, we use something called the Bortle scale. Bortle scale, it was created by an amateur astronomer back in 2001. His name was Bortle. And a low Bortle number, like 1, that means a very beautiful sky, minimal light pollution. The sky is extremely dark, and most of the night sky objects are going to be clearly visible. A high Bortle class number, like number 9, is going to mean that the sky is bright. So bright night skies means that dim stars, planets, and nebula, they're going to be really hard to see. And in order to establish which criteria meet which number, there are certain regulations that are in place. So for Bortle class number 1, astronomers need to be able to see the Sagittarius region of the Milky Way, and it has to cast obvious shadows. So that's one of the requirements for class 1. So astronomers and astrophotographers, they use the scale to compare visibility levels across sites. And then we can flip to the next slide and we can show you what some of the site numbers are here in Minnesota that you saw in the picture. So you can see that Minnesota, it's a home to a complete different range of Bortle classes. So the darkest sites, class number 1, they can be found in the Boundary Waters area. And then the brightest locations are going to be here in where I'm coming from in Minneapolis. So downtown Minneapolis and St. Paul. So we can imagine the night sky above our heads as this big cosmic ocean. And the cleaner the water is, the deeper we can see the stars, the nebula, and the planets and objects it holds. And this is a way to measure that depth. All right, so next I'm going to be talking about the unintended and harmful impacts. So before we go on to one of the first reasons, I just want to point out that light pollution has only been increasing across the world due to urban development, growing populations, and access to electricity. These are all reasons why we're seeing more and more of it across most countries everywhere. Over the past decade, we've seen a 6 to 10% spike each year in North America. And maybe if more people were conscious about some of the negative side effects that the light pollution leaves behind, we could work better to establish healthier policies and just practices for mitigating the effects of light pollution. So here are some of the unintended ones. The first one I'm going to talk about are the effects on wildlife. So during the entire development of multicellular organisms, invertebrates, mammals, plants, animals, primates, and then humans, there was this constant signal that we got from the environment that this is daytime and this is nighttime. And I'm talking about the sun. So all these organisms' bodies, their lifestyles, and their patterns, they evolved around the sun rising and falling each day. But suddenly, humans have introduced this new light source into the game, and it's drastically confused and hurt the wildlife who are used to this typical sun time. So to put it in a better perspective, and something that helped me understand it, was listing a few examples about specific organisms and how light pollution hurts them. So for one, light pollution disrupts the migration routes that birds are taking, and they become more complicated. So most birds migrate, and most actually migrate at nighttime. So this is because they tend to be safer from predators in the dark, and weather can be calmer and cooler. About 200 species of birds, they fly their migration paths at night over North America, and they're going to be using the stars and the polarized light from the setting sun to set their internal compasses and know which direction they should be heading. But light pollution from streetlights, from office buildings, houses, whatnot, it can confuse them, and it attracts these birds. So the birds will start being fixated on these light sources that are unnatural. And in many cases, these birds are often seen to continuously circle around these sources of lights, thinking that they're heading home until they reach the point of exhaustion and they pass out on the floor, which you can see in the case of this image of this seabird here. The Twin Cities has been named one of the worst urban areas in the country for migrating birds, not only because we have a lot of nighttime lights, but because of the amount of birds that we have passing through here. It's an estimated percent of 60% of North American birds that fly over the city. And so that's really hurting how they can travel safely at night. Another reason is nocturnal population. So this has rapidly dropped because of light pollution, and this affects entire ecosystems who rely on this fertilization. So insects are going to see the lights, they're unable to use their nighttime vision or navigate and to know in their internal clocks if it is their time and their shift to go pollinate some plants. Sea turtle hatchlings are often known to instinctively follow the light of the moon and crawl towards the sea. That's how they know to get to the water safely. But city lights from those inland sea towns are shining so bright, brighter than the light of the moon, that the turtles will head in that direction, and often case that's where they end up dying. So although aquatic life lives in seemingly a totally different ecosystem than we do above the water, they also can feel the effects of light pollution. So species of fish, they're going to inhabit different depths in bodies of water. Surface fish are more sensitive to the red light, and more deeper living fish are more sensitive to blue light. So light pollution alters the colors and intensities, which disrupt their normal living patterns because they're not sure what depth they should be at. And this is the feeding, schooling, and migration routines. And of course, trees have also begun to have trouble adjusting to these seasonal variations because they rely on the sun and light. So because of this excess light, trees are being seen to bud earlier and lose their leaves later than normal. And this changes the productivity of the entire ecosystem as trees are really relied upon. And finally, predators are able to hunt better at night. And this changes the whole predator-prey relationship that we see balancing ecosystems. So you would be right to assume that our own health is also linked to the effects of light pollution. When daytime ends and darkness sets in, our brains are programmed to produce this hormone called melatonin. But at higher light levels, this production is suppressed. And so sleep, digestion, and blood pressure, they're all important cycles that are regulated by our biological clocks. And the one ticking the minute hand is melatonin, but it is no longer ticking the minute hand. So basically this means that without the signal from our brains that it's our body's time to rest, we simply will not rest, and we're going to stay up later and have a harder time falling asleep when we finally decide it's time to do so and turn off the lights. So this realization is linked to several medical disorders in humans, such as depression, breast cancer, and cardiovascular disease. So we need sleep, but when the world around us is overly bright, what can we do? The third effect I want to talk about is carbon emission. Light pollution is tied to forms of typical pollution that we're more familiar with as well. I'm talking about greenhouse gases warming up our planet. So when you plug something in, it feels purposeful. You're defending yourself. You feel like you have a reason to do it. But the truth is 1/3 of all outdoor lighting in the United States actually ends up being wasted. It doesn't serve a purpose at all. This is a result of over-illumination. This is when artificial light sources is used well beyond what is required for a specific activity. So for example, keeping the lights on all night in an empty office building. So these sources, they still add up to billions of dollars of coal and oil each year that are burned, and those pointless burnings still release their carbon emissions, which will then hurt the environment. Okay, the last point I want to talk about is more on the philosophical side, but I feel like to us as astronomers here, it's really important to point out. So it's estimated that 1/3 of the human population will never get to see the Milky Way with their naked eyes in their lifetime. Looking up the night sky in awe of its beauty and wonder, it's such a profound human experience that generations today are missing out on. And it reminds us of how small we are and how much we're a part of something greater still. And so it's it's something that we shouldn't take for granted, and hopefully we can learn to mitigate the effects of light pollution so we can all still have this experience. Okay, from this point, I'm gonna pass it on to Anjana, who will speak more about the effect that light pollution has on our work as astronomers and the ways we can mitigate its effects.
Perfect. Thanks, Ramona. So as Ramona mentioned, sky glow is one of the most commonly observed forms of light pollution, and it really affects astronomy. Just to see how this is, so let us take a look at a few images. So the image right here, you can clearly tell that you can see the stretch of the Milky Way on the image on the left, whereas this is not really visible on the image on the right. That's because of the sky glow that's interfering with our observation of the dark skies. The image on the next slide, if we can go to that, yes. This image depicts the Bortle scale that Ramona mentioned earlier, but in images. So as a recap, Bortle scale is a 9-level numeric measure of the night sky's brightness in a particular location. So it basically quantifies the astronomical visibility of celestial objects and the interference that is caused by light pollution. So this is an image from the Sky Glow project, which I'll be talking more about in a little bit. But looking at this scale, as Ramona said earlier, a scale of 8 to 9 is very bad for astronomical observations, and a scale value of 1 is considered really good. So on the next slide, we have some real images taken in various locations around Minnesota. And, it goes up all the way from the Bortle class 2 to 9. And, you can kind of tell how barely any stars are visible in a scale of 9. So now I want to talk a little bit about how astronomical data specifically is affected by light pollution. And one of the main things that comes to mind is how they affect light spectra. So I'm going to take a second to talk about what spectra are here. Spectrum is obtained from splitting the light from the telescope into its component colors. So the image on the top right kind of depicts this. You can see how incoming light is kind of split into its component colors on the other side. So when you take a spectrum of objects like galaxies, you will see that the spectrum is not continuous. So a continuous spectrum looks like the first bar on the image on the left. We typically observe that the spectra don't look like that. Instead, they seem to have a number of lines in them. So those are the examples given on the image on the left, like below the continuous spectrum. And you can see them for elements like sodium, hydrogen, calcium, mercury. And each of these lines is a unique indicator of the presence of a certain chemical. So by studying the strengths of these lines, we can deduce the chemical compositions and temperatures of the objects we're observing. And by noting how far these lines are shifted from the red side, we can tell how fast these objects are moving. The plot on the right at the bottom, that typically shows how we as astronomers study spectra. It's a plot of flux or intensity as a function of wavelength. And you can see features like emission lines and absorption lines that you can further study. So now let's come back to our main issue at hand, how light pollution affects spectra. So this is a spectrogram of a galaxy in the constellation of Hercules, taken by the 200-inch telescope at Palomar. The redder colors are towards the left, and the bluer colors are towards the right, wavelength-wise. And the bright horizontal line in the center is the galaxy itself that we're observing. And typically, spectra like this tend to have relatively fainter lines of actual data, but all of the bright vertical lines that you're seeing are actually from mercury vapor lamps in San Diego. So all of the, as I indicated on this slide, all of the actual lines of data are very hard to find because all of these bright lines from mercury vapor lamps interfere with that. And obviously, this is a problem. So let's think about ways to mitigate light pollution. The first thing that comes to mind, let's go to the next slide. And the next one. Perfect, yeah. So the first thing that comes to mind is kind of what Ramona already mentioned earlier. It's shielding of streetlights to help focus all of the light downwards. So there's not any light that's getting reflected, causing sky glow, or other sorts of light that interferes with general observation of the sky. This also helps save electricity in many ways because this is an optimal usage of light. A second one is to use sodium vapor lamps instead of mercury vapor lamps. And this is because, as you can tell from the diagram on the left, the image on the left, mercury vapor lamps have an enormous number of these spectral lines in all parts of the spectra. So they interfere with astronomical observations right from infrared all the way up till ultraviolet. And they're super bright, as we could tell from that spectra or spectral image that we looked at earlier. And sodium vapor lamps have only 2 lines in their entire spectra. So if cities use sodium vapor instead of mercury vapor lamps, then we would have a much easier time analyzing spectra as astronomers. And unfortunately, there's no other way to filter out light pollution from astronomical data. So honestly, the only way is for people to take steps voluntarily and switch to using shielded low pressure sodium vapor lamps. One thing that I found interesting as part of my whole search about ways to deal with light pollution is this project called Sky Glow. And all of these images that you see on the slide are taken by 2 photographers who are, as part of the collaboration for this project, they're exploring North America's remaining magnificent night skies. And this is an effort to raise awareness about the grave effects of light pollution. We do have a small trailer to show you about this, but let's skip ahead and talk about why astronomers use red light for observations, and then we can go back and watch the trailer. So have you ever wondered why, as astronomers, we use red light when we go observing? And you must have also noticed that observatories have red light in them. Well, there is a scientific reason for that. Firstly, have you noticed that at night we tend to see better when we look sideways than the front? The reason for that is we have 2 types of cells in our eyes, rod and cone. And as you can tell from the second image I have up there, they're at the very back of the retina. And what plays a role at night are rods, and they work to detect motion. So they're essentially important for night survival. And they detect light at lower levels, essentially. So there is a chemical called rhodopsin that is produced at night that helps us with night vision. And it takes very low light to produce this chemical rhodopsin. So it turns out that deep red lights do not trigger neutralization of rhodopsin, thus keeping our night vision going, essentially. So even if it were a bright red light, all of the rhodopsin produced would be neutralized and our vision would just go bad. So to avoid that, astronomers use dim red lights to enable their night vision to sustain. All right, so should we go back to the Sky Glow trailer now? It's a pretty fun, it's a very interesting initiative. All right, so coming back to our presentation, hopefully that video gave you an overview of the efforts that SkyGlow is taking to bring this great problem into awareness. So lastly, we have a small activity planned for all of you. So if you've been curious about light pollution levels around the world, here's a link for you to look at. This link will take you to different statistics on what cities shine the brightest. So I think this is pretty fun to watch. We're going to leave this link up, for a minute, just to give you enough time to go to the link and kind of take a look at things. And then we'll come back to the presentation and ask for more questions from the audience.
So I sent the link for this is on your screen, and also I sent it in the chat. So hopefully it should be available for everyone. And we do have some questions already if you two would like to take them.
Yeah, let's hear them.
Yeah,
Yep.
So we've got some questions already, but if anyone on the YouTube has any other ones, please feel free to send those in. The first one of the people on YouTube would like to know, they'd like to hear some comments or opinions about the Starlink program.
So I personally gave, like, my last Universe at Home talk last semester was about Starlink. So I guess I can talk a little bit about everything I remember from that presentation. Starlink is another cause for light pollution, sadly, because they're planning to launch hundreds to thousands of satellites into space every year. And I actually have examples of images where, streaking of light has basically been observed. Like, it has interfered with ground-based telescopes data, essentially. So I'm gonna, how do I share this, actually? That's a good point.
Are you trying to share your screen?
Or maybe I can just send it to you, actually. One sec. But I have a really cool image that shows basically many streaks on an astronomical, image. It's pretty interesting to watch.
I think it'd be easiest probably for you to share your screen.
Okay. Do that then. But yes, here is an image taken off, a few objects in the sky, and all of these lines that you're seeing are Starlink satellites that have interfered with, the data. And this is basically what the scenario will be in the future. All these little dots you're seeing are satellites that will be launched, and they're expected to form a huge network that looks like this. So obviously it's going to be a huge hindrance to astronomical observations.
We have another question from YouTube. Is it by the study of their light spectrum that we know what elements are predominantly on a distant heavenly body? So essentially, how do we know what most of the elements in a celestial body are by studying the light spectrum or?
Yeah, well, I can take this. There are 3 different types of light spectra: emission, absorption, and then there's a third type that I'm slipping my mind. But one of basically astronomers will probe a distant body with radiation, and we watch the wavelength that the elements will give off. So you excite a certain type of molecule, and when that molecule relaxes back to the lower energy state, it gives off radiation, which is in the form of this wavelength. And a wavelength, the value is very specific to which type of atom or molecule that you are probing. And so that's how we know. It's a great question, and it's what astronomy is based around. So that's how we get the spectra, and each spectra is going to be unique to which type of molecule you're studying.
We have another question. What are the effects of newer LED street lighting?
Okay, I could talk about all this a little bit. I don't know the full extent, but when I was doing some research, I found that LED lighting, it's better for the environment, but not in terms of light pollution. The lighting that it's going to give off is very, very bright, and it can have different types of wavelengths that can be seen as more unnatural than the light that we're dealing with. And so one of the good things about LEDs, though, and these new lights that we're using, is that the intensity is adjustable. And so that's really kind of a savior of light pollution as well, to lower those effects. But yeah, for LEDs, they're good, but then they're not as good as people would think they are.
Yeah, actually, just to add to that, I agree with what Ramona said, because LEDs are better for the environment, but not necessarily like dim enough to be able to, remove all of that light that interferes with observations. In that respect, the low pressure sodium is the best when it comes to, the purpose of astronomical observations, at least.
We have another question. With all the satellites and light pollution, is there any reasonable future for ground-based astronomy?
That is a great question that we're hoping to answer ourselves. That is why we, as students at universities, astronomers, we are trying to bring awareness to this particular topic. And that is something that we do hope, with enough awareness and enough steps taken at this point, that, could be, if not totally reversed, at least, solved to an extent, I suppose. Things like, shielding streetlights and maybe switching to low pressure sodium vapor lamps in areas, at least, that where there's good view of the dark skies, is definitely a first good step, I feel, towards eradicating light pollution.
Yeah, I also just want to say too, there are initiatives that citizen science and other groups are putting forth to create like dark sky oasis in certain areas. So there's heavy regulations on which light can be allowed at what times, at what levels, at what intensity, at what color. So as long as those spaces exist, that's where a lot of ground-based astronomy can keep occurring.
Another question that just came in, looking at the light pollution map we provided, what color do I have to drive out to get a reasonable view of the night sky?
It may be helpful to flip back a few slides so we can see the Bortle scale at different, the stars you can see. So just, hop back and I'll tell you when to stop. This one. Sorry, one ahead. Well, this is a great one too, but this is more like using a filter. Yeah, this is actual pictures. So Mike Shaw was the astronomer who went out various locations around Minnesota, taking pictures of these two same stars. So it looks like Bortle class, I don't know what you're hoping to see, but 4 and under seems like you can still see hints of the Milky Way galaxy, which is a great standard if you want to see anything close to what the night sky looks like naturally. And these places are all in Minnesota and across the world too, wherever you're coming from. You might just have to drive out and find them, but thanks for asking. Are there any more questions coming in, Darcy?
Currently looks like no questions are coming in.
Right. Well, please don't feel shy. Send us any questions you have, and we'll try our best to answer.
I have a question for both of you. What's your favorite place to go stargazing?
Thanks for asking the question, Darcy. I can go first. My favorite place to stargaze is, well, my parents have this cabin up in Minong, Wisconsin. And when I head there, I'm able to see the Milky Way. And I like it because I don't know what the Bortle class is. I should actually look that up. But it's cozy and you can get out by the lake and it's very quiet and calm. And the only light pollution that I really see is the lights. There's this one cabin directly across the lake that leaves their lights on. But other than that, everyone else seems pretty respectful. And so you can get this beautiful view of the night sky. So that's my favorite location.
Again, thanks for the question, Darcy. And I don't have a specific favorite location, but I think the mountains are the best for stargazing. And in fact, I'm planning to go to one myself this spring break because ours is next week, and do a little bit of stargazing and Milky Way hunting from there.
We have another question that came in. The examples that you showed all used visible light. Does the light pollution also affect infrared or ultraviolet?
I guess I can start with that question. If you want to go back, actually not back, go ahead to one of my slides and come after. Yes, this one. Actually, go back a little bit. Yes, so that's a great question. I'm glad you realized that. So these are both visible light spectrum. But as I mentioned, the mercury vapor lamps actually also interfere all the way from infrared to ultraviolet. So it has a broader range when compared to sodium vapor lamps. That's one reason why we want to switch to sodium, is because its range is more like narrow.
Another question, with the air pollution improvements due to COVID, has this provided any improvement in visibility?
I can take that. I did a little Googling about that subject because I was curious myself. And it has, surprisingly, when people are using their cars less, going out places less, it does decrease overall pollution effects. But again, these are effects that are not doing anything in the long term. So maybe momentarily during this quarantine, you've been able to see a few more stars than normal, but nothing dramatic enough for any long-term improvements on air pollution or light pollution. But we can hope, and hopefully this will inspire us to, save the Earth.
Another question, someone on YouTube has a place east of Hayward and they find the light from Hayward and the nearby casino interfere with viewing the dark sky. How far away from that kind of source do you have to get a better view?
My bet is on really far, just because of how bright these lights tend to be. If you go back to the Bortle scale, so a couple of slides. The one before this, actually. It specifies where you have to be able to see good amount of, dark skies. So city, suburban or city areas and bright suburban areas and suburban sky, like all the way up till 4, all you can see is either no stars or very little stars in the sky, very few, I guess. And, between 1 and 4 is when you have the best viewing. So I would say areas that come under rural or, like specifically classify as dark sky sites, those are the best. And typically, mountain ranges or isolated beaches, they tend to fall under this, score essentially, or scale, since you're able to see the stretch of the Milky Way and whatnot.
So there are dark sky sites are like an official term. I'm blanking on the name right now, sorry. But there are a lot of different groups that will go to dark sky sites with a specific intention of stargazing, which I think is really nice because then you aren't just like wandering out into some farmer's field for stargazing, and that's always a little awkward. So that's always nice, finding local astronomy groups so you can like separate from people, but with people go to dark sky sites.
Also, one thing I want to talk about that we didn't really address in this talk necessarily, but our moon is a natural form of light pollution in that sense, right? Because whenever you have some form of bright moon, you can't really see any stars surrounding it. I once went stargazing during a waxing gibbous just to see how much that affected the amount of stars I could see. And this was at a very like isolated beach kind of area. And I did manage to see some constellations, but that's only because this came under almost like a rural sky. So like a Bortle scale of 3, essentially. So if I were saying like a suburban sky, I probably wouldn't have seen anything with the moon right next to the sky, essentially.
Another question that came in, is there a similar pollution in radio astronomy from things like cell towers? And I think Ramona and I got to experience this a couple years ago.
There is, but perhaps Darcy can talk more clear about it.
Okay. So that is definitely a thing with a lot of radio waves and stuff with cell phones. If you're going up to certain telescopes, you actually have to keep your cell phone off the entire time, which is something we had to do when we were visiting telescopes. So in certain areas where they're doing observations in certain wavelengths, you do have to turn off your cell phones or certain things so that you don't mess with it. Another question that came in, are there any drawbacks to using low pressure sodium lighting?
The biggest drawback that I found is that it's not really aesthetic, at least to our eyes, essentially, because it has a weird orangish glow to it. I can show an image of that really quick, actually, because I have it pulled up. I'm trying to zoom in a little bit here. So I guess, obviously we want bright light sometimes to be able to function properly, right? And we also want our streets to be well lit and whatnot. So there's a general preference towards LEDs as opposed to using high pressure or low pressure sodium vapor lamps. But at least for astronomy's sake, having low pressure sodium lamps in areas where there isn't a lot of human population, but there are good regions where you can, do some stargazing and whatnot, or observations. That might be a good first step. That way, people are happy about having LEDs throughout, and their astronomical observations are not interfered with. Do you guys have anything to add to that? All right. Do we have any more questions coming in, Darcy?
Not at the moment.
I'm not sure what our time is here, like how good we're doing on the time, but let us go back to the SkyGlow link again, and there's a really cool time-lapse video that I think will be very interesting for people to watch. Just to, close off this nice presentation here today. Not this one, the other one, the SkyGlow. This one, yes. I think if you go to videos on the top, I'm not sure how the sound works for this, Darcy, so maybe leave yourself unmuted, just in case. I'm not sure if...
Yeah, I couldn't figure out the sound for the last one, but
Yeah,
we did have a question that came in.
Okay.
What about things like lighthouses or cruise ships impacting aquatic life? And are there things that we can do about that?
One more time, Darcy.
What about the impact of things like lighthouses or cruise ships on aquatic life? And is there anything that can be done about that?
Okay, that's a good question. Yeah, cruise ships and aquatic life. So we saw that light pollution does have an effect on aquatic life. Light will traverse easily through water. So on the scale of cruise ships, though, we are seeing a huge influx of cruise ships and trade practices. So I would expect that, yeah, it would have a negative effect on those ecosystems. And it's light pollution studies on aquatic life. I found that they're quite hard to measure. But my instinct would say yes. And the same thing with lighthouses, kind of connecting that back to light pollution. Lighthouses the purpose is to be bright objects that people are going to be able to see and are hard to miss. And so in terms of astronomical observing, you wouldn't want to stargaze near a lighthouse.
Okay, I think I've correctly pressed the right buttons for sharing with sound.
Okay, perfect. So do you think it's a good idea to play the trailer again for people who missed it, or should we do a time-lapse video?
Let's just do a time-lapse video.
All right, so if you scroll down a little bit, any of these are perfect, really, but I would like I guess pick one that you really like.
I think this one's got some nice colors.
Okay.
I got goosebumps. I'm always a big fan of those shots, those time lapses where you can see everything go around the North Pole star. And they had to wait for a night without much cloud cover. That was good.
I bet, and they're doing this over various locations in North America, which is pretty cool.
Oh yeah, our background images today are also from the SkyGo project. We should point that out.
Yes, there's a specific reason why we picked these, because we wanted to show you that the universe is beautiful, you know, at night. Yeah.
And it looks like we are just about at the end of our time. And no additional questions have come up. So thank you so much for watching and asking all your questions.
Yes, we had a great time having you with us today. So thanks for tuning in.
Thanks so much. Bye.